In this final video, we assemble everything to give our aircraft the wow factor it deserves. Alright, here we go. The workshop is available, although we are sharing the space with another aircraft. The plan is more or less in place. Most of the new components have already been ordered and delivered, and we have the official approval from the club management. Many thanks to the suppliers, everything worked out perfectly. So deep breath and let's begin. First, we had to remove all the old systems, dismantle the electrical setup, and take out the pressure lines. That part was not particularly difficult, but we knew exactly what was waiting for us next. We worked in parallel wherever possible. The instrument panel could be handled independently from the rest, as could parts of the electrical system, and the third work site was the paint shop. Yes, the old paint is gone. Over the years, the aircraft had lost much of its appeal, partly because the paint simply did not look good anymore. That has now changed. With a lot of painstaking effort, the team sanded off the old coating and repainted everything. And it was not just the interior that needed attention. The air brakes, the seat shell, the base of the instrument panel, the front section of the canopy, and more all required refinishing. The wiring required careful planning. There are quite a few cables, and they all need to have the correct length. On top of that, everything had to be routed in a way that allows the entire upper section to remain removable without awkwardly cutting wires. We spent quite some time figuring out the optimal layout. The battery monitors are excellent, but they were missing a proper mount, so we designed and 3D printed one ourselves, including integrated strain relief. Since we absolutely do not want anything catching fire, we secured all exposed areas with heat shrink tubing and protective cable sleeving. Routing the wires to our new control stick was not exactly straightforward either. That required quite a bit of disassembly and reassembly, but now it looks seriously impressive. The cables for the speakers, the batteries, the control stick, the antenna, and the ELT run along the floor of the fuselage. The entire electrical distribution system is now located at the base of the instrument panel. That is also where you will find the fuses, the battery selector switch, the USB port, and the charging socket. The power distribution blocks are 3D printed as well. They almost look store-bought. The entire electrical system has now been renewed and, hopefully as you can see, is extremely clean and well organized. We even drew a nearly professional wiring diagram, which should make future maintenance much easier. The engineering work for the new front panel was the most intense part of the entire project. As explained in Part 1, we first had to get the dimensions exactly right and then carefully position all the instruments. We tested this several times beforehand, machining everything from inexpensive wood, which was also much faster to mill. Once we were confident that this would be the final version, we produced it in carbon fiber. Carbon fiber is an extremely hard material and requires special milling bits with diamond toothing and diamond coating. Standard cutters do not even survive a single pass at 0.5 millimeters material removal before becoming blunt. We seriously underestimated that. Fortunately, the milling bits themselves are not very expensive. We had access to a Snapmaker 2.0, which only offers limited milling performance. Still, it had the advantage of being able to print and mill. Since carbon fiber dust is not exactly healthy, we also built an extraction enclosure around the machine. The entire process took at least 10 hours and destroyed nearly 10 milling bits. The result, however, speaks for itself. Total cost, €44 for the carbon fiber sheet, plus 10 milling bits, assuming you already own the printer. The 20 beers that came with it would have been consumed anyway. How to mount the new front panel to the instrument structure. Yes, we bonded it, and we had to make sure that as much surface area as possible remained for the joint to create a proper load-bearing connection. After all, it has to withstand up to 9G. We used an aviation-approved epoxy resin with added flock fibers as adhesive. The parts were bonded together and held in place with plenty of clamps while curing. It is now rock solid. Of course, before bonding anything permanently, we checked that all instruments fit perfectly and that the cable lengths were correct. The result really does look sharp. Installing the instruments themselves also takes time. On the back, lock nuts keep everything securely in place. And then comes the final detail. We wanted 4mm socket head screws everywhere, so we even drilled out the threads of the older instruments to match. Unfortunately, the transponder only has 3mm mounting holes. Since it is brand new, we did not want to drill it out. To maintain the consistent 4mm look, one of our club members turned down 4mm screws to 3mm shafts on a lathe. That means we now have identical screw heads throughout the entire panel. Sorry, but if you are going to put in this much effort, it might as well be perfect. What was urgently necessary was the renewal of the air pressure system supply lines. First, we used 3 different colors for the static pressure, the dynamic pressure, and the tech probe. Second, we used different types of flexible tubing. However, you have to be careful that they don't get kinked. That's why we also redesigned the mounting for the lines, produced it ourselves using a 3D printer, and equipped it with proper hose openings. Everything now looks very tidy and well organized. Thanks to a coupling, the instrument panel pod can also be disconnected and removed easily. Nice, isn't it? To increase the endurance of the batteries, after all, we now have a new computer that draws up to half an amp. We installed new solar panels. The old panels had around 30 years on their backs. The new ones should be significantly more efficient in power generation. Since the cockpit surface is slightly curved, We fitted 2 panels. They are connected in parallel and feed their power into a charge controller, which in turn supplies 2 batteries in 2 separate charging circuits. We 3D printed the mounting brackets, and the electrical connections are routed under the canopy. For easier maintenance, the system can also be disconnected via plugs. We also did something to improve our safety. When looking into the sun or directly into bright, reflective clouds, it's possible not to notice a glider that's on a direct collision course. A canopy strobe can help in this situation, or at least increase the chances of being seen. Installation was straightforward, but make sure the connection between the canopy and the nose section is properly tight. The unit we installed here can even flash faster when it detects a FLAM-equipped aircraft on our course.